Hi everyone, I am Bindeshwar from Post Network, and in this video you will know about joint probability mass function and marginal probability mass function. So let us define what is joint probability mass function in brief. So if you have two-dimensional discrete random variable, then joint probability mass function of x and y denoted by pxy and is defined as pxy xi comma yj probability x is equal to xi's events, y is equal to yj's events. But to understand clearly, let us take a practical example. So I am taking the example of tossing 3 coins. So if you toss 3 coins, you will get the following sample space. Here T denotes tail and H denotes head. So we will have 8 possible events. Now on this sample space, I am going to define 2 random variables, where x is a random variable which denotes occurrence of heads and y occurrence of tails. So x can have 4 values. 0, that means that there is no head, 1 head, 2 heads, 3 heads. The same way, there is no tail, 1 tail, 2 tails and 3 tails. And the probabilities of events would be, if there is no head, so this is your favorable case, only 1. So probability would be 1 upon 8. 1 head, there are 3 favorable cases. This one, and this one. So probability is 3 upon 8. Also this one is also 3 upon 8, and all are heads, means x is equal to 3. Probability is 1 upon 8 because there is only 1 favorable case. The same way, y is equal to 0 means there is no head. So probability is, you can see that only 1 favorable case, so 1 upon 8. 1 tail, so you can see that this one, and this one, 3 favorable cases. So probability is 3 upon 8 for a 1 tail. For a 2 tails, this one, and this one, also 3 upon 8 probability. For a 3 tails, you can see that only 1 favorable case, so 1 upon 8. Now let us see the joint probabilities. So see that here x is equal to 0, y is equal to 0. It indicates that probability of having 0 head and 0 tail. So this is not possible. So I have written probability 0. Second one is also not possible. Third one is also not possible. Fourth one is possible. It is telling that x is 0, 0 head and 3 tails. So that is favorable case. The same way here, 1 head and 0 tail. This is not possible. I am crossing now. This is not possible. 1 head, 1 tail. This is not possible. 1 head, 2 tails. That is possible. 1 head and 3 tails. No. Then the coins would be 4. That is not possible. Showing that coins should be 4. That is not possible. 2 heads, 1 tail. That is not possible. 2 heads, 1 tail. That is possible. You can see from the list. It means 2 heads and 1 tail. 3 favorable cases. That is possible. You can see that that is not possible. Not possible. 3 heads, 0 tail. That is possible. Others, this one not possible, not possible, not possible. Now see that tabular form of joint probability function. So see that here these are the values of y which are in red one, and these values of x, and these you can say that the probabilities. For example, this shows that 3 heads and 0 tail. This shows that 2 heads and 1 tail. This shows that 1 head and 2 tails. This shows that 0 head and 3 tails. So this is the joint probability function. Now see that here the green one, these are the marginal probabilities. You can say that of random variable x, and see that this one is marginal probabilities of random variable y, associated events, and you can see that there's some 1 upon 8, 3 upon 8, 3 upon 8, 3 upon 8. That is 1 upon 8. That is 1. So this summation is also 1. This one is also equal to 1. So these are on margins of tables, border of tables. So that's why name is marginal probabilities. So marginal has come from because they are on the margins. That's why they are called marginal probabilities, and they can be derived from a joint probability table. Now let us see that here marginal probability mass function of x. See that px 0. So px0 I am calculating in terms of x and y, pxy. So px0, so it would be always 0 here, and y will vary from 0 to 1, 1 to 2, 2 to 3. So px0 means it always be 0, and combination with all possible values of y. So that would be 0, probability 0, 0 and 1 upon 8. So total 1 upon 8. Px1 means here 1, always 1, 1 and 1, and y will vary from 0 to 1, 1 to 2, 2 to 3. And see that probabilities you will add 3 upon it here. The same way px is equal to 2, px2, 2, 2, 2 and 2. Here y will vary 0 to 1, 1 to 2, 2 to 3. So if you sum all probabilities, 3 upon it. px3, so 3 here, all possible values of y, so px y, so that would be, see that y is varying, so calculate the probabilities, so you will get 3 upon 8. And one thing, that sum of all marginal probabilities 1. The same way marginal probability mass function of y, p y0, here you will see that y will not change, now x will change, 0 to 1, 1 to 2, 2 to 3. And see that from the table you can see the probabilities 0, 0, 0, 1 upon 8, so total probability 1 upon 8. Here x will vary from 0 to 1, 1 to 2, 2 to 3, and y will be constant. You can see that in this case, and see the probabilities, so that is 3 upon 8. py2, you can see that 0, value of x is varying from 0, 1, 2, 3, but y is 2 always, so sum all probabilities, you will get 3 upon 8. Same way py3, so here x is varying from 0 to 1, 1 to 2, 2 to 3, but y is, you can say that always 3. So get all probabilities, here 1 upon 8, 0, 0, 1, 0, not 1, 1 upon 8 plus 0 plus 0 plus 0 is equal to 3 upon 8. Sorry, it should be 1 upon 8. It should be 1 upon 8. So you are finding here py0 in terms of pxy, or here px in terms of pxy. So here px is marginal probability, and you are getting it from joint probability mass function. So this was about joint probability mass function and marginal probability mass function. Hope you have understood the video. Thank you very much for watching the video.